So today we are going to continue our work with angles, which we were working with last week. Our focus today is going to be on angle pairs, so a relationship or things we know about pairs or two angles. So the first pair that we are going to talk about, if you flip open that angle relationships, okay, we have adjacent angles. When you write down definitions, you do not need to. You should not be writing them word for word. Read the definition, put it into words that makes sense to you. So we're talking about adjacent angles. That word adjacent means next to. So when we're talking about adjacent angles, we're talking about angles that are next to each other. The geometric definition says two coplanar angles. Coplanar means they're in that same flat surface with a common side, a common vertex, and no common interior points. So when we look at that, again, it just means two angles that are side by side. When I look at the examples 1 and 2, angles 1 and 2 are adjacent angles. They have a common side, they have a common vertex, but no interior points. Okay? If I had some points up here, they'd either be in angle 1 or in angle 2. They're not overlapping and in both of the angles. Okay? So when you read that definition, it seems confusing. If you think about what the word adjacent means next to. These two angles are next to each other. They're touching. They share that common side. Same thing with angles 3 and 4. They are adjacent angles.
Wait.
Okay, so again, we don't need to write it down word for word. Okay.
Wait. Okay. The illustration.
So number one says to name the angle adjacent to angle 3. So angle 3 is this yellow angle. What angle is adjacent to angle 3?
Angle 2.
Angle 1 has to be touching angle 3. Okay, it shares one side. So angle 1 and angle 3 are adjacent. They're right next to each other. Number 2 says name the angle adjacent to angle ABD. So what's an angle adjacent to angle ABD?
Angle BD. No, angle DC. No, DBC.
Angle DBC. Or we could switch the C and the D around. Remember, trace it with your finger to get those letters in the right order. Number 3 says to name the two angles adjacent to angle YZW. So what would be one angle that's adjacent to angle YZW?
X, Z,
Okay, angle XZW. What's the other adjacent angle?
Y,
Angle YZV, the one here. Okay, so again, those adjacent angles need to have one side that they share. Number 4 says to name the angle adjacent to angle AFB. What angle is adjacent to angle AFB? Pardon? AFE. Can't use AFE, and the reason for that is when I name that straight angle AFE, okay, we don't know if we're coming down below or if we are coming across the top. Okay? If we're coming across the top, then they would not be adjacent because they would both have common interior points that are in here would also be inside the great big one. So what could we name? Angle BFC would be adjacent because it shares this common side. Ray FB. Are there any other adjacent angles?
no. Angle BFD.
Okay, we could name angle BFD. It's a bigger angle, BFD. Anything else?
They were all of them down.
Okay, what would be another one? Is there any others?
BFE.
Right, angle BFE would be another one. Okay, so several different options there. They just have to have that one side that they share. Okay, that's where the two angles touch each other. So those are adjacent angles. Okay, just a relationship. We can't determine anything just because they're adjacent. We don't know anything about their size. But some of the other angle pairs, we're going to know information about their sizes. And one of those is complementary angles. So complementary angles are two angles whose measures have a sum of 90. Two angles whose measures have a sum of 90. So two angles are going to add up together to equal 90 degrees. Several ways that we could see that and work with complementary angles. In this first example, we know angles 1 and 2 are complementary because of that right angle box in the diagram. We don't know anything about the specific measures of angles 1 and 2. It doesn't matter. We know that they are complementary because they form a right angle, which is 90 degrees. In the other example, we know angles A and B are complementary because we know their angle measures, and added together, they are going to equal 90 degrees. So again, several different ways that you can know that angles are complementary. So number 1 says if the measure of angle H and the measure of angle J are complementary, find the measure of angle J. So if I know angle H is 28, how much is angle J?
$62.
62 degrees. Okay. Added together, they have to equal 90. Number 2 says to name a pair of complementary angles. So what would be a pair of complementary angles?
AFB and BFC.
Angle AFB and angle DFE. Is that what you said?
No. AFB and BFC.
And BFC?
Yeah.
Do we know that those two angles are complementary?
Yeah.
How do we know that?
No. B.
He said BFC.
BFC. Do we know that those two angles are complementary?
Yes.
How do we know that? Jean, how do we know they're complementary?
Because they're adjacent to each other and they're right side by side.
Okay, they're adjacent, but that doesn't mean they're complementary. How do they have to add up to 90 to be complementary?
Because of that right symbol down there.
Okay, but my right symbol is for these two angles. Okay, those aren't the two angles that you gave me.
Yeah.
So do I know that these two angles that you gave me are complementary?
I know why, I just don't know how to explain because if
Okay, do we know that it's a right angle?
Because one side of one of the angle lines lays flat, and the other one is straight up, forming a right
Okay.
angle.
So we cannot say that those two angles are complementary because we don't have angle measures that show they add up to 90. We do not have the right angle box to show us that they are a right angle. You cannot look at a picture and say it's a right angle. It has to have the box, or it has to tell you that it's a right angle. Okay, you have to know for sure. You can't say it looks like it does. And that's something that is confusing, okay, in geometry, because we look at the picture and we say, well, it looks like it's a right angle, okay? In geometry, we cannot make that assumption that it's a right angle, okay? So which pair of angles do I know are complementary?
BFC and CFB.
Okay. Angle BFC and angle CFD. Okay. I know they're complementary because of my right angle box. So that's something you really have to be careful of, is those 90-degree angles.
What if we measure it with a protractor?
No, we don't even do measurements with a protractor unless we're specifically told to measure with a protractor. Yep. Because a lot of times our pictures aren't necessarily drawn to scale. For example, if you look at number 1, okay, 28-degree angle, 62-degree angle. When you look at them, you don't really see a whole lot of difference in the pictures. Okay. So again, we have to use the information that's provided for us. Good questions. Number 3 says find the measure of two complementary angles, A and B, if the measure of angle A is 7x plus 4 and the measure of angle B is 4x plus 9. I'm going to have to do some algebra here. What kind of algebra equation can I set up? What am I going to do with those angles? If they're complementary, what am I going to do with them? Add them.
And set it equal to 90.
Very good. Add them together and set it equal to 90. So I'm going to combine like terms. 11x plus 13 equals 90. I'm going to subtract 13 11x equals 77. I'm going to divide by 11. X equals 7. Not done though, because they want me to find the two angles. So angle A is 7 times 7 plus 4. So 49 plus 4 is 53. Angle B is 4 times 7 plus 9. 4 times 7 is 28, plus 9 is 37. And a quick check, if I add these together, they equal 90. Question?
Yes. So, this is not a question, but
Okay, if it's not a question, then we're going to keep going, okay?
is that a quicker way? Don't.
Okay, whatever you need to do to show work is fine, but this is what needs to be written. The original problem needs to be written because that's what our rule says. Complementary angles are two angles that add together to equal 90. Whatever you need to do to show work to solve is what you do. Not everybody's is going to look the same.
So we
Okay.
have to show.
You need to show some work, yes. Number 4, we want to find the value of x. So what are we going to do for this one?
So we group them together like number 3.
So I'm going to take my two angles, 3x plus 8 and 8x plus 5, and set it equal to 180.
To 180?
I'm sorry, to 90, thank you. I'm getting ahead of myself, knowing what's coming up. Equal to 90. So I'm going to combine like terms. 11x plus 13 equals 90. Seen that before, haven't I? 11x plus 13 equals 90. So I know that x is equal to 7, because I already did the work on number 3,
That's all I want.
and that's all at once. So we're done with that one. Okay. If you wanted to check your work, you could substitute it in for those two angles and see that they add up to 90. Next angle pair is supplementary angles. Supplementary angles are two angles whose measures have a sum of 180. So two angles that add up to 180. So you need to know that complementary is 90, supplementary is 180. Again, with the examples, 3 and 4 are adjacent angles, and we know they're supplementary because they form that straight angle when we combine them, and we know a straight angle is 180. With angles B and C, they give us the angle measures. So we know that 43 plus 137 equals 180. So we know they are supplementary. So again, two different ways that you can see those angles.
I don't understand
Pardon?
the illustration.
These two angles make a straight angle, which is 180 degrees.
Oh.
B and C give us angle measures that add up to equal
That's
180 degrees.
Right.
Okay. So, number 1, if the measure of F and G are supplementary, find the measure of angle F. So how much is angle F?
48.
48 degrees. Number 2 says to name 2 pair of supplementary angles. So what would be 1 pair of supplementary angles? Yes, Savannah?
DEF.
Angle DEF and
Angle FE.
angle FEH. Very good. What's another pair of supplementary angles? Angle GEH and angle DEG. Okay. So there are 2 examples. Okay. There are some other combinations that we could use also. But again, any 2 angles that add up to 180. So in our example, they make a straight line.
DEG is what she meant to
Oh, DEG, thank you.
Wait. Okay.
Number 3 says to find the measure of 2 supplementary angles, A and B, if the measure of angle A is 3x minus 7 and angle B is 2x plus 2. So they're supplementary, which means they add together. So 3x minus 7 plus 2x plus 2, they equal 180. So I combine like terms, 5x minus 5 equals 180. Add 5 to both sides, 5x is 185. Divide by 5 to find that x is 37. But they want me to find the 2 angles. So angle A is 3 times 37 minus 7. 3 times 37 is 111 minus 7 would be 104. Angle B, 2 times 37 plus 2. 2 times 37 is 74 plus 2 is 76. And again, if we add those 2 together, they do equal 180. Number 4, instead of telling us they are supplementary, we can see by looking, they form a straight angle, which is 180. Here I'm going to do some distributing. Again, multiplying by the fraction 1/4 means we're dividing by 4. So we get 9x minus 2. The other angle, we're multiplying by 1/2 or dividing by 2. We get 3x minus 10. So those 2 angles are added together to equal 180. So I'm going to combine like terms. 12x minus 12 equals 180. I'm going to add 12 to both sides. 12x equals 192. Divide by 12. X equals 16. They want me to find the 2 angle measures. I'm going to use what I came up with after I did that distribution. Still get big numbers, but not as big as if I was multiplying by 36. So I have 9 times 16 minus 2. 9 times 16 is 144, and 144 minus 2 is 142. 3 times 16 minus 10. 3 times 16 is 48, minus 10 is 38. And again, if I add those two together, they equal 180 degrees.
You put the 9 and 12. This is.
It doesn't matter. Just showing that we're multiplying. 9 and 16. Our next angle pair are vertical angles. When we look at the definition, it says vertical angles are two angles whose sides are opposite rays. If we have opposite rays, what do those opposite rays form? They form a line. So vertical angles are formed when two lines intersect. Okay. When we look at the picture in the example, when I look at that, I don't think of opposite rays. I think of two lines. Okay. But again, those two lines are made up of opposite rays. So when we're talking about vertical angles, when we have those two lines that intersect, angle 1 and 2 are vertical angles. Okay, so they're not adjacent. They don't share any sides. Okay. Angles 1 and 2 are vertical. Angles 3 and 4 are vertical. Okay, they're not adjacent to each other. Using what we know about supplementary angles, which we just talked about, we can even determine something more specific about vertical angles and their measures. So, for example, if I said that this angle 1 was 40 degrees. If angle 1 was 40 degrees, how much would angle 3 have to be? 140, because angles 1 and 3 are supplementary. They have to add up to 180. So if angle 3 is 140, how much does angle 2 have to be?
40.
It would have to be 40. If angle 2 is 40, how much does angle 4 have to be? 140. So now when I look at my vertical angles, angles 1 and 2, what do I know more specifically about those vertical angles? What are they? What do I know about their measures?
They're equal.
They're equal. They are congruent. So we know that vertical angles are congruent. The way we show angles to be congruent is you are going to see an arc on the angles, and then you will see that tick mark on that arc. So when I look at that picture, I would know that angles 1 and 2 are congruent. They both have one tick mark. Angles 3 and 4 are congruent. Okay. They have 2 tick marks because I'm not saying they're the same as the other ones. Okay. But vertical angles are always going to be congruent because of what we know about supplementary angles. Number 1 says to name the 2 pair of vertical angles. So what's 1 pair of vertical angles?
3 and 4.
Angle 1.
Angle 3 and 4, I heard. What else?
Angle 1 and 2.
angles 1 and 2.
Do we have to put the plus sign?
What?
Do we have to put the plus
It's
sign?
an and sign. So yes, when you name a pair, you have to name 2. So it's angle 3 and angle 4. Number 2, name the angle vertical with angle VZY. VZY. So what angle is vertical to angle VZY? Which angle is vertical?
VZX.
Angle, which one?
VZX.
VZX.
Oh, not vertical.
Yep.
Oh, XZW.
There we go. XZW. Okay, vertical angles, that's going to be on those opposite sides. Okay. VZX would be adjacent. Number 3 tells us that line LM and line NO intersect at point P. So again, anytime 2 lines intersect, we have those vertical angles. We want to find the value of X. So again, I'm going to need to set up an equation. What can I do to set up my equation for this one?
7 plus 13x equals -30 plus 16.
Okay, I'm going to set them equal to each other because they are vertical angles. We know vertical angles are congruent. So here I've got a variable on both sides. I pick on the little guy, get rid of the 13x. So 7 equals -20 plus 3x. Then I can add 20 to both sides. 27 equals 3x. I will divide by 3. X equals 9.
That's it.
And that's it for this one. Okay. Again, if you wanted to check your work, plug the value in, find each angle. They should be equal to each other. Same kind of thing with number 4. We know that line AC and line DE intersect at point B. So we have vertical angles that were formed. We know vertical angles are congruent or equal to each other. Again, I've got a variable on both sides. I always get rid of the small one. So 20 equals x plus 15. So I'm going to subtract 15 to find that x is equal to 5. And again, that's all the further I need to go with that one. Number 5, find the value of x and each angle. If angle SOP is 5x, so I'm going to put that in my picture. And angle ROQ is 4x plus 10. So very important to put it in our picture so we can see that relationship. So with it in the picture, looking at that relationship, again, I know I have vertical angles which are congruent or equal to each other. Variable on both sides. So I subtract 4x and find that x is equal to 10. They want both angle measures. So SOP is 5 times 10. which is 50 degrees. The other angle, 4 times 10 is 40, plus 10 is also 50 degrees. They're equal to each other, which is what I needed to have happen. And then in number 6, I've got 3 lines that intersect. We can look at any 2 lines and find vertical angles. So we've got 6 different angles. They told us the measure of 2 of them. We have one that's 41, we have one that's 72. We need to find the other angle measures. Lots of different ways we could start, work through this. What's one angle measure you can give me? Okay, so angle 1 is how much? Okay, angle 1 is 72 because of the vertical angles. What else do I know? Angle 3 is 41 because those are vertical angles. I have to find 4 and 2.
There's 67.
Okay, and how did you come up with 67?
I subtracted 41 and 72 from 180.
Okay. So if I look at this horizontal line and look at the top, I had an angle that was 41. Angle 1 we said was 72. The 3 angles together make that straight angle, which we know has to be 180. Okay, so Josh said he added the 41 and the 72, subtracted it from 180 to find 67. And if angle 4 is 67, then angle 2 is also 67 because they are vertical angles. The last pair that we're going to identify is what we call a linear pair. We've already seen some linear pairs when we've done some of the previous examples. The definition says it's a pair of adjacent angles, so we know they have to share a side, whose non-common sides are opposite rays. And earlier, again, we said that opposite rays form what? A line. So if I have opposite rays that are the non-common sides, then they have one side that is common that makes them adjacent. So anywhere I'm going to draw in this common side. So angles 1 and 2 are a linear pair. They are a pair of angles that form a line. So again, we've seen some pictures similar to this. What else do I know about angles 1 and 2 that we've talked about today?
They're supplementary.
They are supplementary, which means they are going to add up to 180. Okay. So again, something that we've worked with previously. Number 1 says to find the measure of angle 2. How much is angle 2 going to be if the other angle is 138? 42 degrees. Number 2 says to name all the linear pairs. What's one pair of?
Angle 5 and angle 6.
Okay. Angle 5 and angle 6. What's another linear pair? Yep. Okay. Angle 7 and angle 5. What's another linear pair? Angle 7 and angle 8.
Angle 8, angle 6.
Angle 8 and angle 6. So those are all of the linear pair possibilities in that diagram. 3 says that line LN and line OP intersect at point M. We want to find the measure of those two angles. So when I look at my diagram, what do I know about those two angles?
They are intersected. They're linear.
It's a linear pair, so what do I know about their measures?
They're equal to
They are equal to what?
1.
They are equal to 180, which is our straight angle. So I combine like terms. 12x plus 30 equals 180. So I subtract 30. 12x equals 150. I'm going to divide by 12. And I get 12 and a half. Okay, so x is 12 and a half. They want me to find both of those angles. So 7 times 12 and a half plus 20. 7 times 12 and a half is 87 and a half plus 20 is 107 and a half. 10 plus 5 times 12 and a half. 5 times 12 and a half is 62 and a half, plus 10 is 72 and a half. And again, if I add those two together, it does equal 180. So I know I worked it correctly. Number 4, same kind of thing. We know that angles 1 and 2 are a linear pair, which means they add up to equal 180. I'm going to go ahead and do my distribution. Multiplying by 1/3 means I'm dividing by 3. So 9x minus 2 plus half of 6x minus 20 gives me 3x minus 10. Those two angles add together to equal 180. So I combine like terms. 12x minus 12 equals 180. So I add 12. 12x equals 192. Divide by 12 to find that x is equal to 16. And for this one, that's all they wanted me to find was that measure of x. Number 5 says to find the value of y and each angle if the measure of angle SOP is 7y minus 12 and angle SOR is 5y plus 12. So again, I like to label that in my picture so that I have that visual. These two angles form that linear pair, so they are supplementary. They are going to add together to equal 180. So I combine like terms. 12y equals 180. I divide by 12 to find that y equals 15. And then they want me to find the two angles. So 7 times 15 minus 12. 7 times 15 is 105 minus 12 is 93. The other angle is 5 times 15 plus 12. 5 times 15 is 75, plus 12 is 87. And again, I see that those two angles added together do equal that 180. Number 6, we want to find the value of x and each angle. If angle DBA is 4x plus 6, and angle DBC is 11x minus 6. So again, I've got that visual. I can see I have a linear pair, which means those two angles should add together to equal 180. So I'm going to combine like terms. 15x equals 180. Divide by 15 to find that x is equal to 12. And then again, I need to find my two angle measures. 4 times 12 plus 6. 4 times 12 is 48. Plus 6 is 54. And then 11 times 12 minus 6. 11 times 12 is 132. Minus 6 is 126. And again, I'm able to check my work, see that those two angles add together to equal 180. And then on the next page in your interactive notebook, we have an angle bisector, similar to what we talked about with our segment bisectors. An angle bisector is a ray that divides an angle into two congruent angles. So when I look at my example, I have this large angle WXY, and then I have this ray XZ, which they are calling the angle bisector of the large yellow angle WXY. So because it's an angle bisector, it's dividing the angle into two congruent angles. So to show that congruency, we put arcs on the angles and that one tick mark. So I know those two angles are congruent. They have the same measure. So looking at this example, they tell me that ray FG is bisecting angle EFH. So again, because I know that it bisects, it is cutting that angle into two equal parts. Then they tell me that the measure of angle GFH is half of 10x minus 20. So I distribute that to get 5x minus 10. And angle EFG is 3x plus 25. So again, because I know I have this angle bisector, I know these two angles are congruent or equal to each other. So I'm going to subtract 3x from both sides. 25 equals 2x minus 10. Now I can add 10 to both sides. 35 equals 2x. And I can divide by 2 to find that x is 17.5. Next, they want me to find the measure of angle GFH, which is my 5x minus 10. So 5 times 17.5 minus 10. I'm going to work out, which gives me 77.5. They want me to find angle EFG, which is the 3x plus 25. So 3 times 17.5 plus 25. When I work that out, I get an answer of 77.5, which is a good thing because, again, I have an angle bisector. These two angles should be the same. The next thing they want me to find is the measure of angle EFH. Angle EFH is the yellow angle that you see. So there I'm using my angle addition postulate that we worked with previously. These two angles added together, 77.5 and 77.5, give me a total of 155. And then the last one, they want the measure of angle IFE. And angle IFE is this angle. Here we can use what we know about supplementary angles because we have this great big angle all the way around that we know to be 180. The yellow angle was 155. I subtract that from 180. I'm left with 25 for angle IFE. So you're starting to see as we continue to learn more and more how different things tie together. And we're able to use multiple things that we've learned to completely solve problems as we did here. And we started out with the idea of the angle bisector to find angles GFH and EFG. We used angle addition to find angle EFH. We used what we know about straight angles, supplementary angles, to be able to then find angle IFE.